Right, notes 3.5 on solving quadratic equations. This is the first day of this set of notes. And before we actually attack these problems, there are a couple things that I want to make sure you guys truly understand, okay? If I tell you that A times B equals 0, then I can conclude that either A equals 0 or B equals 0, okay? So, if I have A times B minus 5 in brackets equals 0, I can conclude that either this A has to be 0 or this B here has to be 5, okay? Because in order for me to get these things to multiply together to give me 0, either one has to be 0 or one of these factors has to be 0, just like we discussed in class, okay? It does not work if I tell you that A times B equals 12, because A could be any real number and B could be any real number, because we're allowed to have all sorts of fractions and decimals multiplied together to give me 12. But numbers multiplied together to give me 0, one of them has to be 0, okay? So this, I can't really make any conclusion from it. Well, why does this matter? Well, because this is A to the power of 1, B to the power of 1, so this is a second degree term right here. So whenever we have anything with a second degree term, aka a quadratic equation, we need to set it equal to 0 and factor it, because once we factor it, that means that we have two things multiplied together to give me 0, which means that one of them has to be 0. Okay? All right, so first example, x squared minus 7x equals negative 10. Well, I'm not allowed to have it be equal to anything other than 0 once I see a squared here. So I need to get everything on one side. So I'm going to say x squared minus 7x plus 10, because I need to add 10 to both sides to get rid of it, equals 0. Now, when I do this right here, do not forget your equals 0 on every single line. Otherwise, it becomes an expression and not an equation. Now, when I factor it right here, I can say that these are going to be x's here, and I can use 5 and 2 because my leading coefficient of 1 is nice and easy. I know that this will give me 5x, I know this will give me 2x, and if they're both negative, it gives me the 7x that I want. So this would be minus 5 and minus 2 here, okay? So now that I've done that, I have two things set equal to, or multiplied together to equal 0. Therefore, just like we said that A times B equals 0, so either A equals 0 or B equals 0 right here, this whole piece right here is like A, and this whole piece right here is like B, and I can say that either x minus 5 equals 0 or x minus 2 equals 0. Well, if x minus 5 equals 0, then x equals 5, and if x minus 2 equals 0, then x equals 2. Therefore, my solution for x has to be either 2 or 5. Now we must put it in this type of brackets and not in these soft brackets here, because this means that x would be 2 and y would be 5. But here, both values of x are going to be 2 and 5. Those are the values of x that solve this equation up here. So this is my answer. Last thing I want to make a note of is the fact that it doesn't matter what order you put this in, but generally we like to put it from least to greatest. Okay, so now in the next example, we have x plus 5 times x minus 8 is equal to 30, okay? So right here, it's not equal to 0, so I'm going to expand this piece right here first to make my life a lot easier, and then I'm going to get it all together on one side, and I'm going to say it's equal to 0. So I'm going to take x and multiply it by x, and I'll get x squared. X times negative 8 gives me negative 8x. 5 times x is positive 5x, and 5 times negative 8 is negative 40. And that's going to equal 30, okay? Now I'm going to collect like terms on the left side. So I'm going to get x squared right here. This gives me minus 3x minus 40 equals 30. But I still have this issue of having this 30 here. So to get rid of this 30, I need to subtract it. When I subtract it, I'm going to subtract it from this 40 right here. So I end up getting x squared minus 3x minus 70 equals 0. And again, it has to be equal to 0 because I have an x squared here. So now I need to factor. So when I factor, again, the leading coefficient is x, so that's nice and easy. So I'll use x and x. And I'm going to look for factors of 70. So I'm going to try 10 and 7. This gives me 10x. This gives me 7x, which does give me the negative 3x I want if the 10 is negative and the 7 is positive. So I'm going to have minus 10 and plus 7 right here. Okay, so now that I've done that, I set each part equal to 0. So I'm going to say x minus 10 equals 0, or x plus 7 equals 0. Well, here x equals 10, and here x equals negative 7. So therefore, my solutions are going to be 10 and negative 7. All right, on the next page, we have m squared equals 7m. So what we're going to want to do is we want to get it all on one side because we have a squared here. So we're going to say m squared, we're going to subtract 7m from both sides, and we get 0 on the right side. Now, a common mistake is people will want to divide by m here and tell me m equals 7 and be done, but that's wrong because if m is 0, then that's illegal. I'm dividing by 0, I will get an undefined fraction. And in fact, m does end up being 0 because the first question you ask yourself whenever you factor here is there a GCF? And there is. I'm going to factor out an m. When I factor out an m, I have an m left over minus 7 equals 0. So here's my first factor. Here's my second factor. So m equals 0 or m minus 7 equals 0. Well, m equals 0 is already solved. When I solve m here, I get 7. So therefore, my solutions would be 0 and 7. Okay, in the next example here, negative 6y squared minus 12 equals negative 27y. My suggestion to you is always have a positive leading coefficient. So this negative 6 is my leading coefficient because it's the coefficient of my highest degree term. So what I'm going to do is I'm going to move these two terms to the right side so that way I don't have to deal with a negative 6. So I'm going to have 0 on this side. When I add 6y squared to this side, I get a positive 6y squared. Then I have minus 27y. And then I have to add the 12, so I'm going to have plus 12 as well. Why am I doing it in this order? Because I want it in descending order. So now I can go ahead and factor it. Right, so the next question we're going to ask ourselves is there a GCF? So looking right here, I can see, yes, there's a GCF of 3. So I end up getting 0 equals 3, and then when I take that out, I end up getting 2y squared minus 9y plus 4. Okay, so then I get 0 equals, keep the 3, and then when I factor this, I want this 2y and this y to multiply together to give me y squared, and then factors here would have to multiply together to give me 4. Now, it would not make sense to put 2 here and 2 here because we already took out our GCF, and 2y and 2 have something in common, so that's not going to work. It also doesn't make sense for me to put a 4 here because, again, 2y and 4 have something in common. There's a GCF here, but there's no GCF here, so that won't work either. So it seems like the only possible solution is for me to put a 1 here and a 4 here, but let's check to make sure it works. So 1 times y is y, and 2y times 4 is 8y, and when I put those guys together, I do get the negative 9y I want if they're both negative. So put a negative here and a negative here. Okay, but this time I have 3 factors. I have 3 equals 0, I have 2y minus 1 equals 0, and then I have y minus 4 equals 0. Well, 3 is impossible. There's no way 3 will equal 0, so I don't even have to worry about this 3 right here. Also, I could have just divided everything through by 3 here, and then I wouldn't have even had a 3 to deal with. And that's also allowed as well because I'm not dividing by anything that's undefined. Then I would get 2y here. I would add the 1 to both sides. So I would get 2y equals 1, so y equals 1/2. And then here, to get rid of this minus 4, I would add 4, so I would get y equals 4. So my solution here would be 1/2 and 4. Okay? All right. Now, let's see if you guys remember the quadratic formula. So let's write it out. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? Now, Couple things, you do want to have this formula memorized, okay? And I strongly suggest that every time you use it, you write it down so you have it memorized, okay? Now, a couple of mnemonic devices to help you remember this. So if you sing this to the tune of Pop Goes the Weasel, it might help you remember it. So for example, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's one song you can use to help you remember it. The other song is to the tune of Row, Row, Row Your Boat. So you can also say x equals negative b plus or minus square root of b squared minus 4ac all over 2a. So those are two options you can use to help you remember the quadratic formula. Okay, so find the roots of the quadratic function below using two methods, the quadratic formula and completing the square. So to find the roots, that means that y is 0. So I'm going to replace 0 in for my y right here. So 0 equals negative 4x squared plus 40x minus 93. Now we use the quadratic formula or completing the square if factoring is not possible, but otherwise factoring is generally the best option. So to figure this out, I'm going to first of all write down the formula. So I'm going to write down the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And I'm looking at my equation here and I'm realizing that a is negative 4, b is 40, and c is negative 93. So when I do this, I end up getting x equals negative 40 plus or minus the square root of 40 squared, because that's what b is, minus 4 times negative 4 times negative 3, all over 2 times a, which is negative 4. Okay? So this ends up becoming negative 40 plus or minus the square root of 40 squared is 1600, okay? And then here I'm going to multiply negative 4 by negative 4 by negative 3, sorry, by negative 93, and I end up getting negative 1488. So this is minus 1488 all over 2 times negative 4 is negative 8, okay? So then this ends up being right here, negative 40 plus or minus the square root of 1600 minus 1488 is 112 all over negative 8. Now this is where the whole simplifying of radicals is going to come in. So I'm going to get negative 40 plus or minus now 112. I'm going to figure out what can I divide 112 by that's a perfect square. Well, the halfway point is 56, so I'm going to work backwards. So the closest perfect square to 56 that's less than 56 is 49. So I'm going to take 112, divide it by 49, and I'm going to see, nope, that doesn't work. So then the one prior to that is 36. So I'm just using the list that we have on page 3. So 112 divided by 36, that doesn't work out evenly for me either. So the perfect square before 36 is 25. So 112 divided by 25 is 4.48. That doesn't work either. So the one before that is 16. 112 divided by 16 is 7. So 16 is my largest perfect square. So I'm going to split this up into the square root of 16 times the square root of 7 all over negative 8. Okay? So I end up getting negative 40 plus or minus the square root of 16 is 4. So I get 4 root 7 all over negative 8. Now this is where what we learned about factoring is going to come in. Okay, so and simplifying our equations. So negative 40 and 4 root 7 have a negative 4 in common. So I'm going to factor out a negative 4. And when I factor it out of negative 40, I get positive 10. When I factor it out of 4, I get 1, so I get 1 root 7, or just root 7. Now when I factor out a negative out of a positive, I get a negative. And when I factor out a negative out of this negative here, I get a positive. So it still is going to end up being plus or minus root 7 all over negative 8. Okay? Sorry, I'm just going to put all of this work together and make it a little bit smaller because I'm running out of room and I want to make sure that I do all of this properly. Okay, so then I end up getting here, I know that I've got a -4 and a -8, and they can both reduce. The negatives cancel each other out. The 4 becomes a 1 and the 8 becomes a 2. So that means that I end up getting 10 plus or minus root 7 all over 2. So therefore, my two roots are going to be 10 plus root 7 over 2. And then my other root is going to be 10 minus root 7 over 2. These are my exact roots. If I wanted to find out my approximated roots, then I would do some rounding. Okay? All right, so that's what I need to do for the quadratic formula. Now, to complete the square, the idea is very similar. First part is exactly the same. I still set it equal to 0. So I say 0 equals -4x squared plus 40x minus 93. And then remember, to complete the square, we're going to factor out a -4. So I get x squared minus 10x. I'm going to leave some space, and I'm going to write the minus 93 on the end. Now, to complete the square, I have to take -10, this value right here, divide it by 2, and then square it. So I end up getting -5 squared, which is positive 25. So I'm going to say plus 25 right here. But to balance that out, I need to subtract 25. Okay, so here I end up getting 0 equals -4. Remember, we keep our perfect square trinomial inside of here. So x squared minus 10x plus 25. Distribute this -4 to this -25, and I get positive 100, and then just copy down that minus 93. Again, don't forget to write down your 0. So I get 0 equals -4. I can factor this here into x minus 5, the whole thing squared, okay? Plus 100 minus 93 is 7. All right, so now that I've done that, I'm going to get rid of this 7. I'm going to put it on the other side. So I get -7 equals -4 times x minus 5 quantity squared. Now I want to get rid of this -4, so I'm going to divide both sides by -4. So I get -7 over -4 equals x minus 5 squared. But the double negatives are allowed to cancel each other out, so I can just say it's 7 over 4. Okay, now in order to get rid of this square, I need to square root both sides. So I end up getting the square root of 7 over 4 is equal to x minus 5. But don't forget that when you square root something, you have two possible answers: positive square root of 7 over 4 and negative square root of 7 over 4. Okay, so then I'm just going to rewrite this over here, and then like that, equals x minus 5. To get rid of to get the x by itself, I get rid of this minus 5. So I get 5 plus or minus the square root of 7 over 4 equals x. Now, this answer looks a little bit different, and we're going to talk about why it looks different. First of all, I cannot square root 7. But I can square root 4, and I get a 2 in my denominator. So this is the first piece right here that's important that we make sure we understand, okay? So therefore, my two roots are going to be 5 plus the square root of 7 all over 2. And then the other root is 5 minus the square root of 7 all over 2. But notice how here it's 10 over 2, and this is 10 over 2 here. And when I divide it, I end up getting the 5 that I'm looking for. Okay, so those are two options that you have. Again, these are exact answers, not rounded answers. Have a great day.